Hi students, I hope you're doing well in your exams. So today I'll be talking about limits, continuity and differentiability. So first let's talk about limits. Let's take any function f of x which is equals to x square minus 1 by x minus 1. At x is equals to 1, we are trying to find out the value of this function. So the value of the function would take a form of 0 by 0 which is undefined. So we try to find out the limit of this function by taking the approximate values near to the function f of x at x is equals to 1, as I already told you. So let's draw a table first. So at x is equals to 1, when we simplify this function, we get it as x plus 1 into x minus 1 by x minus 1, which is nothing but x plus 2. When we substitute one value, we get the function as the value as 2. So at x is equals to 1, the value of the function is 2. When we take a near value which is greater than 1, for example 1.1, then the value of the function would be 2.1. And when we take a little higher value than 1.1, let's say 1.2, the value of the function would also vary to 2.2. Similarly, let's take a value which is very less than 1, a very small value, let's say 0.9. The value of this function would again be 1.9. Similarly, if we take 0.8, it would be 1.8. So here what we are understanding is, as the value increases very smallly, the function of the value would also tend to 2. For example, as the value of the function coming from right side, that is when you decrease the value, then it is tending to 2. It's similarly when the value of the function tending from left side to 1, the value of the function would also come to 2. So this is what is the limit of this function. So for any function, we try to find out the nearby values for which it tries to coincide is what we are trying to find out. Now let's take a small example. Yes. The limit of the function for limit x tends to 0, sin x by x minus sin x at x is equal to 0 is what we are trying to find out. Now first, for limit x tends to 0, we try to simplify in the form of sin x by x minus sin x. So we write it as 1 plus x minus of sin x by x to the power of sin x by minus of sin x minus x. We are just trying to make it simpler. We are trying to find out in the form of 1 plus t whole power 1 by t. Okay, we are trying to bring this in this form. So for limit x tends to 0, 1 plus sin x minus x by x whole power. This is nothing but we can also write x by sin x minus x into minus sin x by x. Alright, we have just replaced, we have just multiplied and divided by x here in this thing. So it is nothing but in the form of 1 plus t whole power 1 by t, and for limit x tends to 0, sin x by x is anyway 1. This we already know. So this is nothing but e power minus 1. So the limit of this, and we also know that limit of x tends to 0, 1 plus t whole power minus 1 by t is nothing but e power minus 1. So which is nothing but 1 by e. I hope this is clear. Now let's solve next equation, next question. We are trying to find out the limit at x is equals to 3, x minus 3 by under root of x minus 2 minus under root of 4 minus x. So how do we find a limit for this? So it is that we are going to rationalize this numerator and denominator multiplying under root of x minus 2 minus under root of 4 minus x. That is limit x tends to 3, x minus 3 by under root of x minus 2 minus under root of 4 minus x multiplied by under root of x minus 2 plus under root of 4 minus x. Similarly, okay, so now I'll separate this limit into two things. That is, I'll write limit x tends to 3, x minus 3 by when you multiply this, it's in the form of a square minus b square. That is x minus 2 minus 4 plus x. I've taken minus this side. Limit x tends to 3 under root of x minus 2 plus of under root of 4 minus x. So here what we do is we are trying to find out that for limit x minus 3 by 2 times of x minus 3. This, after simplifying, we get this. Limit x tends to 3. This is nothing but 3 minus 2 is 1 plus 4 minus 3 is 1. So for this the value is 2 and for this the value is 1. So the complete limit is 2 for this function. Okay, so this is how we try to find out limits for functions where you have to use rationalizing. You might have to do the rationalization of this denominator and still find out the function. Okay, now let's talk about the continuity. What is continuity? A function to be continuous, the left hand limit that is f of a minus 0, that is nothing but limit h tends to 0 a minus h, or this is what is the left hand limit. Similarly for the right hand limit. So these two should be equal. Left hand limit should be equal to right hand limit and should be equal to the value of the function. So for a function is said to be continuous for which the left hand limit equals to the right hand limit and it is equals to the value of the function, that is at that point f of a. Alright, so to understand this better, I think I'll take an example. So test the continuity of the function at x is equals to 1. So the function says that f of x is equals to x square minus 4x plus 3 by x square minus 1 for x not equal to 1 and 2 for x is equals to 1. So what we do here is when we substitute the value 1 here, it is again in the form of 0 by 0. So we first simplify this equation. What we do is f of x, which is nothing but x, this you can still write it as x minus 3 and x minus 1, right? When we multiply x square minus 3x minus x, that is minus 4x, minus of minus, that is plus 3, divided by x minus 1, x plus 1. So this we can just cancel and we write f of x as x minus 3 by x plus 1. Now we try to find out for the limit left hand limit. So when we try the left hand limit, for the left hand limit we substitute in this equation limit x tends to, or you can anyway you can take anything, since we are finding it for 1, x tends to 1, x minus 3 by x plus 1, and this, since it's left hand, we take negative. Okay, so a negative value would be coming here, that is minus h minus 3 by minus h plus 1. Alright, so 1 that would be equals to 4. Similarly, when we take for right hand limit x tends to 1 positive, that is we are coming from the right side, then it is again the same thing. Yeah, so this is not the same thing, but here we would be getting 1, so it is -1, which says that the limit is discontinuous, because it is not the LH, the left hand limit is not equal to right hand limit, and also it is not equal to the value of the function. See, at x is equals to 1, the value of the function is 2, so it is not even equal to 2, so the function is discontinuous. Okay, I hope this is clear for you. Now, what do you say? What do you say by, what do you mean by differentiability? So a function is differentiable if the same function is continuous. All right, so now to find the differentiability of a function, we say that r dash, that is the right hand limit when differentiated, should be equal to the left hand limit when differentiable. So differentiated, so it is also written as f of x minus f of x plus h by h, that is limit h tends to 0 should be equals to limit h tends to 0 f of x minus h minus f of x by h. So the function is differentiable when it is continuous, but the vice versa need not be true. That is, for example, if the function is not continuous, then it is not differentiable. But if the function is differentiable, it means that the function should be continuous. It need be and need not be on the other way. Okay, so let's take a small example. Okay. First, we try to find out this we will first do. So we are trying to find out the function f of x, and we check whether this function is differentiable or not. So to check this, first we have to check the continuity. So the continuity says that for r, we'll take first RHL. Okay, so RHL is nothing but here limit h tends to 0 h sine 1 by h. Okay, so the function when h tends to 0, h sine 1 by h is nothing but 0. Okay, but for function on left hand limit, when we take a negative value of this function, this is again limit h tends to 0 but minus h sine of minus 1 by h, that which is also again equal to 0. So which means the function is continuous. Since at x is equal to 0, the value is 0. At RHL it is 0. At LHL it is 0. But now we will check what is the differentiability of this function. Okay, so to check the differentiability of this function, let's take the, as I already told you, we'll write it in terms of f of x minus h minus f of x by h, that we would be writing it again here in that particular format. So for any function to be differentiable, we take RHL differentiated, that is nothing but limit h tends to 0 f of 0 plus h, right? But we are trying to basically find a similar value to this. Okay, so yeah, yes, the function is continuous as I already told you. So in this, okay, so what we do is here sine 1 by h by h, because here whatever f of minus f of 0 is anyway 0, right? Okay, so this is where I was confused. So do not get confused at this point. If you write the entire formula, then it will be easier for you to find out. So which is nothing but h. So here sine 1 by h tends to 0. This is undefined. Because sine 1 by h is an oscillatory function, it is not defined at any particular point. So the differentiability at RHL itself says that it is undefined. So it is not differentiable. It is only continuous because RHL and LHL is equals to the correct value of the function. Okay, so this is how we try to find out. So we substitute the values of h and a. So where you wanted to find the value and write in terms of the formula, and then we try to figure it out. Okay, now it is saying that, let's take another example which says find the values of a and b such that f is continuous at x is equal to 0 for the function 1 plus mod sin x whole power a by 1 by mod sin x for x less than minus pi by 6 to 0, and b for x is equal to 0, and e power tan 2x by tan 3x for x less than 0 and less than pi by 6. So here it says that it is already continuous. So when it is already continuous, it is x equal to 0. We first try to find out left hand limit, then we try to find out right hand limit, and then we equate to the value at which it is continuous, that is f of a. Here it will be f of 0, since at x equal to 0 we are trying to find out. So for the function for less than, or probably we can also take at x, so it is L equal to R, which is equals to V, the value of the function, which is equal to B. Why is it equal to B? It is because at x is equal to 0, the value is B. So we have just equated all the 4 things. Okay, now for writing the limit for LHL, the left hand limit, it is limit h tends to 0 1 plus mod of minus h by a by mod sin minus h, which is nothing but limit h tends to 0. Mod of minus sin h is nothing but sin h. H is not the hyperbolic function here. Please don't get confused. It is just the, instead of sin x, I'm just writing in terms of h. That's all. So 1 plus sin h a by sin h. It's nothing but it's in the terms of 1 plus t whole power a by t. The limit of this function is nothing but e power a. Alright, we already know that limit h tends to 0, 1 plus t whole power a by t is nothing but e power a. Now, which is nothing but b. Now, for x greater than 0, we would be considering this function. So we again equate this e power tan to h limit I'll be using this, okay, limit h tends to 0 e power 2h by tan 3h, which is nothing but limit. So this is for positive, for the greater than value. So we are just trying to find out for 0 plus also you can consider. Okay, so for any limit tan theta and theta tending to 0, this is approximately equal to theta. So this is something that you might have to remember, and this will be very important for your exams. So these type of formulas, I think it's better you remember before you go to your exam. So it is limit h tends to 0 e power tan 2h can be written as 2h, tan 3h will be written as 3h, which is nothing but e power 2 by 3. Now this, since it is continuous, I am just trying to equate e power 2 by 3 to b. 2 is also equals to e power a. So the value of b is e power 2 by 3, and a, when you equate the powers, a will be equals to 2 by 3. So this way we try to find out the continuous function, and if it is already given, if the function is continuous, we try to find out the value of a and b. I hope this is clear. Okay, So we have another problem which talks about the continuity and differentiability of the following function. So we have to just discuss. So first we'll try to find out the continuity and this differentiability of this function by drawing a graph. Okay, so y is equals to x square. So the x square function would pass through origin, okay, because at x equal to 0 the value is 0, and because we also have for -2, for any less than -2, let's take this is -2 and this is 2. So for -2 the function value will be 4, and for 2 the function value will be 4 again. So that is where the graph comes this way. Okay, now and for x the y value is 4 for function x is less than -2 and less than 2. For greater than -2 and less than 2, that is, it will be somewhere like this. Okay, so this is at -2, 4. This is 2, 4. Okay, so now what do we do is, let's try to find out the continuity of this function first. So the continuity of the function, how do you find out? Again, the limits. So the limit h tends to 0, 0, and at what point are we trying to find out? At x is equals to -2. Okay, so here we write it as h tending to -2. Okay, sorry, we are trying to find out the differentiable points at -2. Okay, so we write limit (0) and it is -2. Okay, h tending to 0, and at point of -2 we are trying to find out. Okay, so it's nothing but -2 minus 0, okay, whole square, which is nothing but 4 is the limit of this. That this is nothing but LHL. Now we take RHL, which is limit, again h tends to 0, but for x greater than 2 the function would be this. Okay, the point at which we are discussing is -2. So for anything that is greater than -2, the function you will take is 4. So that is 4, which is nothing but 4. So the function is continuous, since at x is equals to -2 the function is 4, and at this point also the LHL and RHL the value is 4. So it is continuous. This function is continuous, okay, for at point -2. But when we take it for 2, let's see what will happen. So LHL limit h tends to 0, it is 2. For anything greater than 2 it will be this. Okay, so 2 minus 0 whole square, which is again 4. And for anything less than 2 we will be taking this function. So it is limit h tends to 0, 2 plus 0, sorry, it is 4, it is direct 4, which is nothing but 4. So the function is continuous at -2 and 2. Okay, now let's try to find out the differentiability of this function. So how do you find the differentiability of this function? As we already saw, so I'll just take a small space. Okay, so we have already seen that, probably I need to take this away. So as we already know, this f of x is x square for x less than -2, and it is 4 for x lies between -2 to 2, and it's again x square for x greater than or equal to x greater than 2. Now we try to find the differentiability. How do you find the RHL differentiable function? So nothing but f of x minus f of x plus h minus f of x by h. So at x is equals to -2 is what first we'll try to find out. Okay, so it's nothing but -2 plus 0 whole square minus f of minus 2. What is f of minus 2 value? It's nothing but 4, right? By h. Since we are taking RHL, it is just h, and you can just write it as h also, and then we try and limit h tends to 0. So here what we do is we just open, we try to expand this. 4 minus 2h, 4h plus h square minus 4 by h. That is nothing but limit h tends to 0, which is limit h tends to 0, h minus 4. Okay, so the value of the function would be minus 4. Okay, so we have tried the differential function for RHL at x is equals to minus 2. Now we'll find out LHL at minus 2 again. That is f of x minus f of x minus h by h. That is, what is f of minus 2 at the right hand side? Okay, that is nothing but 4, right? So 4 minus f of x minus 2. What is x? Minus 2. So minus 2 of minus h whole square. Why did we take whole square? Because this is f of x minus h, which we are just substituting in x square, alright, by minus h. Because it's a negative word, so when you write it as in the negative thing, then we have to take it as minus h. Okay, so it is nothing but 4 minus 4, or probably this is nothing but h plus 2 whole square. So that is 4 plus 4h plus h square. Minus is outside, you can just take this way, by h. So which is nothing but just simply 4. So what did we get? The function at RHL at x is equals to minus 2 is minus 4. At x is equals to minus 2, LHL, the differential function of LHL is just 4. So we are trying to say that the function is not differentiable at x is equals to minus 2. Though when we saw in the previous thing, it was continuous. The function was continuous, but it is not differentiable at a point of x is equal to minus 2. The similar way we try to find out for x is equals to 2, and let us see what will happen for when we take x is equals to 2. Okay. Okay, so what do we do to find out the differential function at x is equals to 2? At x is equals to 2, we try to find out again RHL, which is nothing but here f of x plus h minus f of x, again limit h tends to 0 by h. So here limit h tends to 0, f of x plus 2, this is nothing but 2, right? So anything greater than 2, we have to take this function. So it is nothing but 2 plus h whole square minus 4, because f of 2 is anyway 4, right? At when x is equal to 2 by h. It's nothing but h square plus 4h plus 4 minus 4 by h. It's nothing but 4. So the limit of this function on the right hand side, it is 4. When h tends to 0, it is 4. And for limit on the left hand side, left hand limit on the differential function, limit h tends to 0, f of x minus h by h. That is limit h tends to 0. What is f of h when x is less than 2? That is 4. Okay, minus 2 minus h whole square by h minus h. So 4 minus 4 plus 4h plus minus h square by h. is nothing but minus 4. So here we could get that the function is not differentiable when x is equals to 2, since right hand limit and left hand limit after the differentiation are not equal. So as I already told you, a function which is continuous need not be differentiable, but a function which is differentiable need to be, or I could say must be, continuous at that particular point. Okay, so I hope you have understood what we are trying to find out. So try solving more problems on this to get a clear idea. Try to learn the formulas, use different ways of solving limits, continuity and differentiability, and this would be an important topic because you might get 3 questions from this chapter. Alright, so this is Shalini. I hope you have understood, and all the best for your exams.